The Edifice Complex podcast is brought to you by DCM, the drawing specialists, Blue Rhythm commissioning software, and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello, Yoda. Okay, I'm interested in this conversation today. I've been thinking about this for a long while. How will buildings be impacted by what we're going through right now?
I didn't sleep last night. Honestly, I didn't. And because we have three members of the CIA with us today. That is the COVID is Airborne group. So with us, first guest is a graduate of Queen's University from Canada. He's a professional engineer specializing in building energy systems and indoor environmental quality. Since the beginning of the pandemic, has helped the worldwide grassroots effort in the design and fabrication of do-it-yourself portable air cleaners, and has been instrumental in public commentary on airborne transmission of pathogens and engineering solutions. Welcome to the show, David Elstrom.
Hello.
Joining us from Ireland, we have a lecturer assistant professor and course director at the University College Dublin School of Architecture and Planning and Environmental Policy. She's a registered architect holding membership with both the Royal Institute of Architects of Ireland. By the way, Ireland is one of my favorite countries, and I'm going to go back there over and over again. Orla, you're going to have to buy us some beer when we're over there. Take us to some of the best pubs. She's also a member of the Royal Institute of British Architects. Her research area is in the built environment, including design, construction, regulation, and procurement, with a particular interest in safety and sustainability. And since 2020 has been in the research in the environmental aspects of the pandemic, and she's been an invited expert advisor to the government. Welcome to the show, Orla Hegarty.
Hello, and thank you very much for the invitation today.
You're most welcome. Then joining us from Scotland is with the National Health Service and co-founder of Fresh Air NHS. She's a graduate at the University of Edinburgh, first earning a Bachelor of Science as a parasitologist and entomology, if I get that right. Then went on to get a Bachelor of Medicine and Surgery, and awarded fellowship with the Royal College of Pathologists in clinical microbiology and virology. Her specialist area of interest are cystic fibrosis, microbiology, hospital ventilation and design, and antibiotics microbial resistance. An outspoken advocate for quality environments in healthcare facilities. Welcome to the show, Dr. Christine Peters.
Thanks very much. Really looking forward to the chat.
So we would need really at least 3 hours to cover your collective accolades. That's one of the challenges with panel discussions. We don't do it justice with your histories and your accomplishments. So for our listeners, we would encourage everybody to go online and do a little bit more research work in the background of our three guests today. And we would need at least 3 hours to cover today's topic. We have an hour, so damn it. That's all I have to say on that. So let me start off by declaring that for our listeners, that there's an ethical obligation of the design professionals to uphold the health and safety and welfare of the public that we have in the built environment. We cannot ignore that. And that in itself has created some turf wars with infectious disease professional control and public health officials who have really usurped the authority of the design professional within the built environment. And that really means that when you start talking about, and I think now most people around the world understand this is an airborne issue. And because of that, there's a responsibility and an ethical requirement for us as design, well, not me anymore because I'm retired, but for those that are still practicing, we have to pay attention to that, to the health and safety of the people that we're designing buildings for. So recently, ASHRAE's Epidemic Task Force Chair, Bill Baumfleth, who we've had on the show a couple of times, said that minimum standards for non-healthcare facilities aren't enough, and that requirements for sensitive healthcare spaces are generally effective. So we're going to talk about that statement But what he did say is what we know for certain is that reducing exposure to pathogens reduces risk. So implementing feasible controls for airborne exposure is a good idea. And I don't think anybody would argue with that at all. Orla, as our voice of architecture here on today's call, where did architecture stand, in terms of airborne pathogen and controlling it, and where are we at today, and where do we need to go in the future?
I think we're in quite a difficult place, actually. I think we've come into this pandemic having lost a lot of historical memory and practice around public health and buildings, and we could go back and wonder why that happened. I mean, some of it is that things were medicalized and antibiotics and things took care of disease and we stopped looking for prevention. Some of it is probably back into the oil crisis and the kind of under engineering of buildings. Some of it is probably over occupancy of buildings that has systemic, I suppose, in a lot of sectors. Some of it is neoliberalism, a kind of deregulatory agenda of hands-off control and compliance. And I don't think we're very well placed to feel confident to deal with the current problems. And I think that's probably been a barrier as well. This is the medical, I suppose it's been easier for medical people to say this is new and we're learning. I think people in the built environment maybe have been slower to say we really need to catch up, and to feel confident about speaking about it. And then having been excluded, I suppose, by the policymakers and medical institutions hasn't helped, because we haven't been at the table to learn and to collaborate on these issues.
Yeah, David, would you agree with that? Is there engineer?
Well, yeah, my mind actually was kind of as soon as we came into architecture as sort of the topic, my mind came to the thoughts of Christopher Alexander's pattern language, and what aspects of that, which is essentially a sort of a timeless way of building and taking into account all of what we've collectively learned over time in terms of patterns and how people circulate within buildings and use buildings. Is there anything that's sort of in that we could draw on in terms of health of buildings? That's sort of back at Orla, I guess.
I think there's an enormous history. The more you look, the more you find, and a lot of things I suppose in recent years we thought of as just good architecture, whether it was high ceilings or good daylight or decent thermal comfort or so many other things, adequate space in homes, all of these things, connection to outdoors, a view of nature and the sky and that connection with the environment, all of those things we maybe started to think of as being more to do with your mental health, when in fact a lot of it was physical health as well. And the kind of loss of the fresh air, high ceilings, adequate ventilation for the occupancy of the space. Back in history, there were quite simple rules of thumb about these things. And in most climates, for most of the year, in most of the world that was heavily occupied, that was okay. We tend to live quite densely in the temperate parts of the world, particularly in the Northern Hemisphere, that are probably reasonably all right in most buildings in the warmer months, but are not in the colder months. And we've accepted, instead of dealing with the buildings, we've accepted seasonal respiratory viruses as just being a given in certain climates, when in fact this could be mitigated. And I think we've, I suppose, pushed our buildings to the limit, because buildings have become about property now rather than people. And they tend to be minimized for minimal compliance, for minimum space, for maximum occupancy, for minimal maintenance. And we've been building up a whole litany of things that were an accident waiting to happen in some ways with the right kind of virus.
Dr. Peters, you've lived that world of buildings being more about property than about individuals within the property. You want to tell us your experience, because you've had some. You were the center of attention as you drew attention to a facility, a brand new facility that didn't meet with your requirements. That's for sure. Tell us about that.
Yeah, so I've been in microbiology for 20 years, and right the way through my training, I was fortunate to work with people who had a real understanding about the importance of ventilation and clean water systems and all the designing out infection agenda that we've had in hospitals. But what struck me all the way through has been this discrepancy between what there should be on paper, there's standards, just like ASHRAE does for the US. We have here standards, the SHTMs, the Scottish standards, which are very similar to the UK standards. And when you find a problem, so as a doctor, the first inkling you might have that there's something going on is somebody gets sick and we grow an organism that you don't normally get as part of the flora. Say it's an aspergillus, that's not part of normal flora. So you're looking for reasons why somebody has this. And it's like having plates, with no disrespect to patients, but they are a very sensitive way of picking up what the organisms are in the environment. So then we go looking, and then you start to discover things like molds in ceiling tiles. And then you think about which way the air is going. And then you start thinking about positive pressure rooms. And so the whole thing unwinds as a story around the patient, as opposed to, I'm not coming at this from an architect or an engineering degree. I'm very much coming at it from the patient. And as I, for the last 15 years, started to discover that, in fact, and it's not just the hospitals I've worked in, it's pretty well across the globe. You start to network and chat to others, and the stories you hear are appalling. Things that are not right. And then when you start the journey of, this room should be positively pressured, but in fact the air is going in the way, so that's wrong. And the amount of opposition you get has been, quite striking. It can be at an education level, so people not really understanding why you're insisting on these standards. And then the other aspect of it is the resource. So a lot of buildings now get 5-star ratings for energy efficiency, which is grand. We're all worried about climate change. That's got to be top of the list. But where the low-hanging fruit is not hospitals. There are plenty buildings out there that you can be integrating smart systems using less air. But if you've got, for example, a bone marrow transplant unit or a suite of theatres, that's not the space to try and reduce your energy necessarily at the compromise of what you need to happen to reduce risk. So it's very much in the public domain here. We have 2 brand new hospitals that have had substantial issues, and it's the subject of an ongoing public inquiry. So I guess I need to be a bit careful what I say, but the standards that exist have not been implemented either in old estate, and that's going back 40, 50 years, and neither in new estate. And somewhere, and I think where COVID is going to change the game, is that people have woken up. 2 years ago, if you said air change per hour, people would look at you blankly. It's gone from a geek issue, right? It's gone from that to, oh yeah, everybody's talking about ACH. Is it 6 or is it 10 or is it 5? Are we going to get away with 5? I don't know. So people are much more educated about it. And I think only good things can happen. But we're waking up to the idea that we have this gap between what we should have and what we actually have. And you're not going to be able to fix that overnight. And that's where the expertise comes in. And because we've got this long gap, and I think just on the other day on Twitter, I saw a discussion where Kath Noakes was saying, we need bespoke assessments of spaces, and we do. But there's so many indoor spaces, schools, businesses, restaurants, hospitals, that haven't been looked at with a professional eye. And the pandemic is now, or it has been, for yesterday, for 2 years. So what can we do rapidly that will change the risk? The simple thing is reduce the number of particles you inhale. So whatever we can get happening, it might not be perfect. That's what we need to do.
Yeah.
But I think coming out of the pandemic, we need a strategy for upgrading everybody's knowledge base. Everybody needs to be on this page. We never want to be coming up against people saying, it doesn't really matter, it's much more important. If you've got 2.5 ACHs, that's all right.
Right.
Because it's 10 litres per person per whatever.
Yeah, a while ago, everybody that teaches, you learn most of what you learn from your students because they ask good questions, right? And they force the ignorance of us out of us, and because we have to go find out the answers. And one of our students said something to me which was profound. I mean, I'd been teaching for a long, long time, and he said, energy efficiency should be the outcome or a byproduct of having good indoor environments, not the other way around, And I thought that was brilliant. And and so we have, since that time, we have used that philosophy, stole it, occasionally give credit where credit is due, but that's a true statement. David, this concept of air changes per hour, just for our listeners, because we have a lot of parents that listen to this program, guiding their kids that are leaving high school, looking at careers. This concept of air changes per hour, why don't you address that just in a brief way so people know what we're talking about?
Sure. This was actually relatively new to me. So I basically learned this with the pandemic because I was just thinking about amount of air per person of outdoor air. But so when we're talking about air changes per hour, you've got a volume of your room, of air in your room. So if you want to air out your room and you have one air change, let's say someone was smoking a cigarette and had left a cigarette. They've left and there's still cigarette smoke hanging in the air. So the question to ask is, well, how many air changes, how many times do you have to change the air in that room to eliminate that contaminant? And people will say, oh, well, you eliminated all it with one air change. Then they'll start thinking, oh, wait a second, no, maybe that's not right. And it turns out to be a relatively simple math thing where it's about 63% gets taken out with one air change, and you just keep multiplying it through each time. So you get diminishing amounts of contaminant remaining until you basically get homeopathic levels of contaminant.
Right, and just so people understand, there's an assumption there that the smoker has left the room.
Yes, that is correct. That is the assumption that, yes, yeah.
And so if you make the analogy to COVID, if a person is in a space, exhales some kind of viral load, that there is a removal of that through the mechanical systems. But if those people remain in the space or more people are added to the space, that's when things are no longer as we know them to be, and that we have to look at other solutions besides just air changes per hour. In-space filtration, UVGI, these other solutions.
Yeah, and the general rule of thumb is 3 air changes, not per hour, just 3 total air changes removes 95% of a fixed concentration. So it's how long there is between that depends on how many air changes per hour there is. And sort of the analogy that's also useful about this, it's all about the mixing. So if you were to try and turn your mug of coffee into milk, you'd have to pour in at least 3 cups of milk, mixing it each time and pouring it out, and you'd still have 5% coffee left at the end of that.
Right.
So you can do other things that are equivalent to air changes per hour, and that's with filtration. You can filter it out and have equivalent air changes per hour with filtration. And likewise for ultraviolet, you can have equivalent sort of kill rates of sterilization of the air with ultraviolet light in terms of many, many air changes per hour.
Thank you for that. So hopefully that clears it up for people. So Dr. Peters, in the hospital environment, a little bit different requirements for ventilation and air quality than we see in houses, for example. And for those that are listening, here in North America, most homes don't have mechanical ventilation. They do in Canada. It's a requirement of our building code. But even those requirements for residential buildings really equate to about a third air change an hour. We're obviously talking a little bit different than that. What David's talking about in terms of pathogen controls in hospitals, it's quite a bit different than even housing. So there's this, going back to this inventory of buildings, and Orla, and there's literally trillions of occupied spaces. I don't even know how you quantify how many spaces there are in the world between residential, commercial, institutional, industrial, and if you think about in a high-rise condominium where there might be 600 units, every one of them has their own environment depending on where they are. They could be at the top floor or the bottom floor. They all have different pressure differentials. So it is a difficult challenge to face. But Dr. Peters, in the healthcare facility, talk to us about the ventilation requirements.
Yeah. So because the people that are in that occupied space are very vulnerable to infection, we have to have much higher standards of cleanliness, both of the environment and the air, which makes sense. So because you've got people, not just people with immune systems that aren't able to fight off. So, you and I might meet a bacteria and fight it off with our immune systems. We'd have to meet a lot more bacteria to cause an infection than some of the patients in the hospital who maybe need smaller numbers. So I was going to say, when David was speaking there, that, reducing by 95% sounds like a lot. But it's not if 5% is like enough to cause 20 infectious doses for the patient. And that will vary according to patient groups. So in hospitals, not only do we have immunocompromised people, we're also doing things to them. So we're sticking needles through skin. And of course, your skin is one of the most protective barriers you have. So we've got lines going in. So then any piece of plastic that's sticking into a vein is going to be a portal of entry. You've got people having post-operative wounds. We're opening up parts of their body that should have no organisms there at all. So hips or brain surgery. So we're doing things to people to make them much more vulnerable, and that's why there has to be a separate code for how buildings are operated. So the standards here are, there's tables of how many ACHs you need and the pressure differentials. But I think one of the differences between here and the States is that we can't recirculate air. So air that's coming in has to go out. So it's one direction. So it's all fresh air. However, we've recently gone over to putting in chilled beams, and that has caused a bit of confusion as to, because I think in ASHRAE guidance you can have a filter, and so as the air gets moved through the chilled beam, then you can count that as long as you have a certain percentage of fresh air coming through. But here we've just calculated the ACH coming in from outside, and there's no filter, so the air just keeps circulating, so it picks up all the dust and the pathogens and gets collected up in the chilled beam. So we've got slightly different guidance, but 6 ACH is the sort of rule of thumb for most clinical spaces. And then you've got negative pressure rooms, which will have 10 ACH, should be negative pressure to 10 pascals. And then we've got positive pressure rooms. And we've also got these rooms called positive pressure ventilated lobbied rooms that came in about 10, 15 years ago. And they're supposed to do a bit of both, a bit of protective isolation and source isolation. And there's quite a few difficulties with that design that we've experienced here as well. But I think with COVID, what we're discovering is that there's a need for something else, which is you can't have negative pressures rooms for 1,000 patients in hospital. That's going to be too much. So we do need to be thinking about something that increases air to an extent that you can provide reduced infection contaminant across much, much bigger numbers than we currently do. I don't know if that's something you've thought of, how we could think about, or ASHRAE is thinking about different solutions other than our traditional negative pressure, positive pressure rooms.
I don't know if you've seen the field hospital that was built in Vietnam last summer for COVID specifically, and they haven't had any staff infection since it opened in August or September.
Wow!
And they don't have all single bed rooms. They have a lot of engineering working around headboards, so extraction around headboards and those kind of features. It looks really interesting in terms of infection control.
Have you got
That makes sense. An
Yeah,
extract
for sure.
at the head, doesn't it? Because that's the PPVL design we have, has either an extract in the ensuite or it allows for an extract by the head of the patient. But some places have put them in where the extract is just in the ceiling, and so you lose the ability to just get directional flow.
You know, the concept's obviously not foreign. I mean, Dave, you think about industrial ventilation systems. Welders is a good example, you know, where they'll bring in a hood just specifically for that process that sits over top of them and the work that they're doing. And any contaminants aren't inhaled, they're sucked into the hood. So these concepts are, you know, are used in other areas. Orla, I wanted to ask you a question. I mean, when Dr. Peters was talking about virus and pathogens, microbials in the healthcare environment, of course, you know, bacteria and virus and mold spores, they don't know whether they're in a hospital or in a home, right? They're
exactly, yeah. I was interested in what you were saying earlier too. I mean, I think I like the word triage now for how we deal with our buildings, because you know, we are on a battlefield in some ways, and we have to deal with the most urgent places first, and then we have to, you know, do enough everywhere else. The way I see it is we can't control what viruses arrive, but we can control whether they become pandemic or not, and that's by ensuring that there isn't that we suppress enough transmission to keep it under control, and that is very much around certain building types that we know are high risk and certain conditions that become high risk. So clearly, it's places. First off, I suppose places that have vulnerable people, like hospitals and care homes. Then we kind of have a second tier of what we might call overoccupied buildings, like schools and places where people socialize and public transport. And then we have the third tier, which is probably homes and a lot of workplaces that are probably okay most of the time, except when the pandemic is really raging. You're not going to get a lot of transmission, but that have areas of risk, you know, people sharing lifts maybe, or toilets that aren't ventilated, or that could probably be managed with good advice and information in a lot of cases, and that we, you know, so we really need to start being, I think, strategic about gathering data about where infection is happening at scale, particularly, and dealing in a very targeted way, I think, with those. I mean, I've done the statistic that in Ireland, half of the people who have died from COVID were infected in fewer than 400 buildings. That's out of 2.5 million buildings. And they were care homes. And, you know, you can start to see the patterns then. And then when you investigate a little bit further, in one county, I spoke to the county coroner. It was a county that's close to Dublin City that has a lot of care homes. And 90% of the deaths in those care homes were in 25% of the buildings. So you can immediately start to do some forensics on what's happening here, and very targeted interventions could make a phenomenal difference, and would have made a big difference. So the same goes with schools. I think, you know, they're clearly engines of infection and disease in the community, and they always were back to 1850 when I found them taking CO2 samples in schools in America in 1850 and bringing them in glass tubes back to labs to see, you know, what the air quality was like. Schools have always been a hotspot because people stay for a long time. They're close proximity, so they can hear the teacher. You know, children can't be controlled to be distanced, and schools are quite vulnerable. So, you know, if we start to use this kind of historical knowledge and current data gathering, I think we could be really strategic about the pandemic. We don't need to do every building. You know, we need to do meat factories and food production that have specific high-risk conditions. We need to do care homes and institutional housing and overcrowded housing, the public transport. These are all things that are themes right through history when there's been disease spread.
Yeah, David, you've been involved in some long-term care facility as an observer commentary. I don't know if you actually got involved in professional practice in these buildings, but actually a question for you first, and then follow up for Dr. Peters and Orla. If the measures that we have or the tools that we have available, the skill set of the building managers, let's take a long-term care facility. Do these individuals, like, we come up with great solutions. We know that from an engineering perspective, but do we have the skill sets within these buildings that can operate these tools that we have available? Managing ventilation, doing filter changeouts, operating or checking, UVGI systems. Talk to us about the skill set.
It's not so much also the skill set, though. It's also the funding and the direction on the management side. So discussions with one retirement home, not really a long-term care home, but a retirement home, where they knew plain well that there was no ventilation. So what are the solutions? Well, you need to get filtration in there right away. You're in an outbreak. You need to do these things. Mm-hmm. But there's no... those who are running the facilities are not necessarily they're doing what they've always done, really. And there's conflicting advice because they're listening to whatever's coming from outbreak management from the public health unit, which is, of course, still droplet and contact and sanitizing surfaces, and not paying much attention to the air side and not involving professionals to help out. I'm just going to switch topics a little bit in terms of, you mentioned before about that energy should be kind of like the outcome of indoor air quality. But I think really energy should be one of the optimizations that we have whenever we're doing any kind of design, in that optimize for lower energy because that's related to cost. But that should be an outcome of like how effective you can deliver clean air is a cost type measure. Mm. So the lower the cost for the higher the benefit is kind of what you want. And that also can be related directly to energy. And we've done that in energy because it costs money to run buildings. And so we have voluntary standards and also sometimes mandatory reporting on energy in buildings. But we need to take that further now with indoor air quality, because there's nothing that says how you do indoor air quality in a building once it's been constructed. There's really nothing.
I want to, so just for those that are listening, so when we talk about indoor environmental quality, that we're talking about all of the sensory systems of the human body. So we're talking about sight, sound, the thermal environment, pressure in terms of vibrations. Obviously, from an air quality point of view, all of the metrics have to be concerned. So going back to the energy, when we talk about, so there's a number of buildings where and I'll talk like the Bullet building in Seattle, for example, or the NL building in Colorado, Manitoba Hydro building in Winnipeg. Those buildings were all designed around human factors. In other words, they were assessed around the sensory system of the occupants, and then from there, that drove the architecture. And even in my own practice before retiring, we and Orla, as the voice of the architect here, you may like this or you may hate this, but we always wanted to deal with clients before they actually consulted with an architect. And so when they left our consult, they left with an environmental specification. So we talked about lumens, and we talked about the thermal environments and the standards that were required to be met, air quality. So these individuals left our office with an indoor environmental quality specification and an energy budget. And then they handed that to the architect and said, okay, Mrs. or Miss or Mr. Architect, here's our IEQ specification, here's our energy budget, now build us a building. And it put the onus on the architect and the design teams to meet that, which is complete reversal than a lot of building practices. And so, Orla, what's your thoughts on that process?
I mean, I totally agree. Like, holistic and considered briefing is key to all of this, and we so many buildings are poorly briefed, and particularly now that a lot of buildings are built speculatively, or that the design is outsourced from the people who will actually occupy it. There's a disconnect there. The people who are making these decisions are very little interest in the experience of the end users, or knowledge or connection with them, or liability to them. So ill-considered. And then I suppose we rely a lot on rules of thumb, rather than thinking more broadly. And I would say that particularly around ventilation. People think of engineering with ventilation, but actually the majority of buildings are not mechanically ventilated, certainly in my part of the world, and they're relying on architects for ventilation design and compliance. And one of the problems in Europe, I think, is that there was a lot of regulation for energy efficiency for climate change, which was centralized. So Europe tends to do things in a way that some things are agreed centrally and come down from the top, but more broadly, it's often agreed as a principle, and each member state decides how to apply it. So energy standards were agreed top down, but ventilation standards were left to each member state to catch up or not, or in their own time and in whatever way they chose. And I think that's left Europe quite vulnerable, actually, because we've been sealing up buildings for the last 10 or 15 years.
The Edifice Complex will continue in just a moment.
Can you find the drawing and supporting documents you need in less than a minute? Now you can with Echo. It's simple. Just type what you're looking for and press enter. Echo knows your building. Speak with a drawing specialist today. Ask about our special offer of painless onboarding plus 6 months free with Echo. Visit podcast.thedsoffer.com. That's podcast.thedsoffer.com.
And now, back to the show.
Adam, do you have any questions? I've been dominating this conversation. Sorry.
Yeah, I've got many thoughts, most of them irrational. What's sort of come out to me is a couple of things. One is what Dr. Peters was talking about. There's this tension between infection control, ventilation rates, and hierarchy in terms of design priority, right? So, if you're designing a AAA office, energy and getting that LEED certificate is a pretty dominant discussion, right? But, I've been involved in lots of hospital biolab projects, and I can tell you that doesn't matter at all. But there's no awareness of that, right? So when you're doing a hospital, as a great example, right, there's, beds have to be a certain place apart, which drives a lot of room decisions, right? There's a hierarchy of needs, to misquote Maslow, where energy is not near the top, frankly. But who talks about this? Right? There is a real lack of advocacy and noise and voice from the medical community. This is really coming through loud and clear to me. It's the old Starkitect thing. Sorry. I'm not.
Yeah, no, I would agree.
Starkitect is always the grip and grin with the architect, right? And no one's talking about the embedded engineering behind it, which is really, really what matters, right? And it's only when you get a crisis like COVID that this brings it through. So, I was fascinated to hear you talk about chill beams as well, because, passive beams, are you talking about active? You're talking about active beams, not passive.
Active chill beams. Yeah, we have them throughout our hospital. I think there's a few things you mentioned, Robert, about is there enough expertise on the ground? Definitely the answer is no. There's poor knowledge base, and on top of that, there's poor practice, and you get that in any profession. So there's a lot of poor practice, but to drive good practice, you need some sort of systematic audit or checking in on places. We don't have a systematic way of going to hospitals and just saying, where are we at with your ventilation validation standards? Or shall I just do a wee smoke test here in your negative pressure room? And it's only when catastrophe happens and, knowing a big range of professionals who've seen a lot of catastrophes, a lot of it isn't published because obviously it's very embarrassing for hospitals, and there's all sorts of public trust issues, or there's always something. So there's a huge gap in the literature, and yet when you talk to people, there's a wealth of information and a wealth of expertise. There are hospitals across the globe that have not opened up properly, or have been a disaster after they've opened that are brand new. Where's the learning from that? Where is that being fed back? So if you've designed and built a hospital, who comes back a year later and says, right, from the porters, the nurses, the surgeons, every single group of people, if you could go back and do it again, what would you learn? What would you like to say to the design team for the next hospital? And also, it's a specialist thing. I mean, it's not like building Tesco's. Building a hospital is very different. So you need people who've done it before and done it before well and got the feedback to tell them they've done it well. You know, they don't just tell the next client, we did it well. How do they know they did it well? And we don't apply that to any other area of science. And for me, the amount of effort and meticulous quality improvement we put into things like the lab results. So most of my job is in the lab. I'm a microbiologist. And we put so much effort into control of the results we put out. And we just don't do that on an ongoing basis with our buildings. And yet, COVID has shown us that is the fundamental thing we need to do, as well as water. I think these are the two things that are coming through. Is water quality is huge as well.
Yeah.
So I think we've got huge ways to go yet.
We don't have a learning loop in the built environment. Unfortunately, most failure is dealt with very privately because it involves money and contracts and embarrassment and accountability. It doesn't get published, and when things go, we only learn from things that go really catastrophically wrong. It's almost like we wait for a large air disaster and we investigate that and we ignore the operation of aviation everywhere else until something badly goes wrong, and we just study the one incident. It's really difficult to get information. There's often a lot of liability involved, and the learning, process just isn't there. If you think about, if we'd applied aviation thinking to COVID, we would be having alerts go out daily from incidents to the community of pilots internationally. We would have mandatory whistleblowing. We would have people being trained about overcoming bias in hierarchies, about these kind of decision making, where we very hierarchical decision making, very closed systems for decision making, very siloed thinking, all of the things that have that work well in other places. We have not taken that and applied it into the pandemic and public health, unfortunately.
That's where the ethics, come in. Robert said at the beginning about the ethics that engineers have, and I know David said that a lot, and that struck me. I mean, it sounds a bit arrogant, but as medics, you think you've got a high level of ethics that you ought to, and I hadn't realised every other profession has similar. Yeah. And so together as professions, we both have an ethical responsibility to the people in our care, if you like. And so part of that ethical responsibility has to be learning from things going wrong. And, things do go wrong and they will go wrong. I can't promise things will be perfect, but we owe it to our patients and personnel and clients to go back and say, yeah, we got that completely wrong. Let's not do that again in the next hospital we build.
Well, it's the common denominator that brings us together as professionals, is the ethics. And yet, and going back to learning, it just seems that part of the team that of professionals forgot about the learning part. I would say, like, in terms of the built environment, that engineers and architects and interior designers, we can't forget them as well, because they play an important role. We've learned a lot. I think if there was ever a profession that has absorbed a lot in the last 2 years, it's the people that are designing buildings. But it seems like those that are representing the healthcare side have said, we know everything, you know nothing, and therefore we're making the rules and you're not. That's from that perspective. It seems to be that was the place. But yet, ultimately, like you said, Dr. Peters, we all have that ethical requirement. And, if we maybe started with that, that maybe we wouldn't be where we are today. So maybe that's one of the things that we can come out of this dialogue today, is that there is a definite need to, once again, to have the healthcare professionals working together with the building professionals going forward, writing standards or guidelines or practices that can be adopted around the world.
So let's have a quick conversation about one of the elephants in the room, politics. So I was fascinated when Paula was talking about, her analysis was there's a few buildings where, like, on an 80-20 basis, 20% of the buildings had 80% of the infections. So as an engineer, that makes so much sense to me. So why are we not doing something about that? And the answer is politics, right?
Mm.
So
politics is how we allocate resources, and unfortunately, this is seen as being. I think this is mistakenly been seen as something that would be very demanding on resources, even though I haven't seen any assessment of what it would cost to fix the buildings anywhere. And I think also there's a sort of sense that there's a view, politics is very short-term thinking, and there's always a view that this is nearly over, it's not worth doing this now. And that was the view in the summer of 2020 and the summer of 2021. And here we are, that we're nearly at the end now, it's not worth our while. And instead of thinking, we know there'll be other variants, we know there could be other pandemics if we don't take preventative action. And every penny spent now would be future-proofing. And it would reduce other disease. We'd have so many side benefits from better indoor air quality in terms of children with asthma being at school more, fewer allergies, less pollution, less RSV and colds and flu and all the other things that keep children out of education.
So, to Dr. Peters and to David, and so does energy at the moment, do you think healthcare, like health, as in like personal health effects, or energy, what do you think is having the priority at the moment? And what do you think that will be post-pandemic?
Currently, it's energy.
Yeah.
And again, it goes back to costs and what happened starting really in the oil shocks, right? We've got to rewrite our codes so that we use less energy. And they went around and closed off the amount of outdoor air going into schools and things like that, and calculating the savings. Look how much I just saved. So energy's there. It's always taken sort of the third sort of position in a company. So it's always been tough to get even energy up to the forefront compared to other main priorities in businesses and organizations. Usually safety's first, but this is an opportunity to tie safety and health back in with energy as well, and get that show those other non-monetary benefits as well. Now I've forgotten what it was you were asking about.
I'm just interested in the priorities here. So maybe actually, Dr. Peters, you're probably the most important voice here. Clearly, energy has had the center stage for a long time now, right? And all of a sudden, COVID has come, and we're talking about infection control. So, have you seen a sea change in your environment, in your work environment, with this?
Not yet. No. I think the potential is there. I think there's just not a deep level of understanding at the level that there needs to be of the fact that you need a multidisciplinary team around the table. So, I mean, everybody here is important because each person brings a different voice. So, you can have decisions made about energy saving and, we'll whack in the chilled beams, and nobody thinks, because why should they? They're not thinking about the patient underneath the chilled beam from which you could get condensation dripping down onto the wounds. Why would you think that if that's not your practice? So you need a multidisciplinary team, and you need the people who are going to work the job. So, the nurses who are going to be caring for the patients, that from where the beds are and how you're going to move things around. You don't know until you speak to the person who says, no, that's not going to work for me. You're going to have to do it in a different place or whatever. It's the same with infection control. But equally, infection control needs to be educated in the engineering terms. I don't need to be an engineer, but I need to understand what the engineering needs to provide for my patients. So I don't know how you're going to get it to 10 ACHs, that's up to you. But I know I need 10 ACHs. And when I walk into the room and I can barely, it's really stuffy, I know there's no 10 ACHs in there, no matter what you tell me. So there's a level of overlap of you need to be able to speak enough language that you understand each other to be able to work it together. So there has been a bit of an increase, I think, in people taking courses on ventilation. A friend of mine, a colleague of mine, Teresa Inkster, Dr. Teresa Inkster, does a master's course in environment and infection control, and they've got a lot of people signing up to do that. And I see there's other courses popping up. The Hospital Infection Society do one. So 20 years ago, it was very niche. You know the three people who are interested in ventilation, and you pick up the phone to them and ask for advice. But we that's not a good place to be either. We need to democratize. We need to share the information. We can't rely on one or two big heads, who have all the brains. We need that information to flow out. And you shouldn't need to wait for the top expert to, gold stamp your decisions. That's become too niche. As soon as you've only one or two people who can make the decision for 100 hospitals, you need many more people who can then, in exceptional circumstances, go for the extra consultancy.
Yeah.
So I think there's a lot of education, both directions. I've tried to do training sessions with estates on infections, and people just don't have an appreciation for something like aspergillus. It takes one spore to cause an infection in a very immunocompromised patient, but you can't see the spores. Yeah. And you can't necessarily even see the mold. But when you've had water dripping into a ceiling tile for 2 months, there's mold there, but you can't see it. So what's the risk? It's like you're imagining a risk. And yet there's so much literature that will tell you that a stained ceiling tile in a unit is not a good idea. Yeah. So those anecdotes, those illustrations, that's backed up. So that could be me as a medic speaking, and they're like, "You're just imagining it." So to have an engineer there together saying, "No, we've both seen this, and this is an issue, and here's how we can fix it." That I think becomes a more powerful vehicle.
There's definitely been a lack of empathy for the person in this whole pandemic. And when I think about some of the designs, hospital designs, there was it was a children's hospital. I wish I could remember the name, but in the design process, they made the different design professionals, so the architect, the interior designer, the mechanical person, get on a gurney flat on their back and get wheeled around the hospital so they could see what it was like to be a patient on their back. What did they see? And it's a brilliant idea, but it just seems that policies and politics has forgotten about the person and in the space. And I think when we start to develop empathy for people in hospital environments, in the schools, in the homes, understanding their physiological and their psychological needs, that's where design ought to start. And you're right, Dr. Peters, it requires an integrated design team. The engineers, the architects, the people that we have here in this call, right? All of our colleagues and our extended colleagues need to be at the table in design.
So
yeah, but I suppose that's where architects come in, and we synthesize everybody else's specialization. It's where it all comes together, and we don't have the technical knowledge of the in-depth of microbiology or of engineering, but the role is to ask those stupid questions and to put people together and to try and learn, I suppose, and to synthesize all of that into solutions. And that kind of thinking, I think, is needed for the whole pandemic in a lot of ways, that we have all of these people working in silos, and people are relying on there's pieces of things to do things, but without any joined up approach about being strategic about it or being long term about it.
So
yeah. Sorry. Yeah. I have so many questions. I know you do too. In the Canadian Building Code, there's a statement, and this is going to get challenged, or it should be challenged, and it's along the lines of the Building Code's about limiting the probability of risk of illness due to air quality, thermal comfort, and exposure to moisture. So going back to mold and the issues that are created by moisture. Limiting the probability of risk due to air quality, David. That we have codes now. If when we talk about airborne pathogens in space, obviously the code's not. It's not compliant. It's the statement itself has created an issue for the building industry because we have not limited the risk of illness. We've exposed people to illness due to air quality. What do we do from here on in? Because I haven't heard anybody. And Orla, maybe that's something that's being challenged in your codes. And Dr. Peters, I don't know about what's happening in your neck of the woods, but if codes are there to reduce the risk of illness, we haven't done it.
Well, I have, if I can find it here, I have a worse one about what our ventilation code says, because it basically doesn't say about anything about illness. It says basically adequate ventilation, but the priority is energy efficiency. And we only build buildings for people. We don't build them just to be buildings. We build them to accommodate people. And if the purpose is to run a building with efficiency, what's the point of heating it?
Well, you may as well have no windows. Shut down the ventilation.
It just seems backwards.
Build concrete bunkers.
It seems backwards. What are we heating buildings for? For comfort and safety and protection of people. And if they can't be in the building safely, there's no point heating them or using them.
Yeah.
Public health has to come up the list ahead.
Yeah, there is a problem though, because I think people think it's a sleight of hand for us CIE type people, COVID is airborne, to start talking about IAQ as including viruses in the air, because that was never in the deal before. So there's a bit of a journey to be gone on before. I mean, I agree, we need to think about air quality with relation to infections, but till now it's really been the domain of TB, and chickenpox sometimes in hospital. And then the really, really infectious diseases like Ebola, which we weren't quite sure is airborne or not. But nobody ever was talking ventilation for flu, not really. So I think we've got that argument still to happen. We know it's in the air, and the amount of data that's now coming out as to this particle sizes and how they behave in different humidities and temperatures, and all of that is coming together. And I think we need new standards that are specific to the infection air quality as opposed to just the particulate air quality. Because otherwise we're talking the same words, and you and I are meaning infection, and others who don't believe in airborne are talking particulate pollution. So we do need to talk about definitions, we need to talk about standards and what they actually apply to keep everybody on board.
Yeah, I think that's a really important point actually, because we're often talking concepts without, we all have a different interpretation of the same concept.
Yeah, I mean, engineering is based on knowns and quantifiable things, right? So when I hear the word adequate, it triggers me. What does adequate mean? Adequate to me means something completely different to you. So David is the engineer, how would you prove adequate? In my opinion, before you answer that, adequate's put in so then there can be some lawsuit based on a horrible outcome that sets a precedent, right? That's just not great. Why can't we define adequate? You're an engineer and you're designing a job. How do you define adequate? How do you defend yourself on adequate?
I've just been thinking about some of the sort of comments that I see from people online, which might be about or just comments from in relation to, say, masking. There is no Goldilocks level of masking. I mean, it's not a just right. What's the just right level of infection? It's there isn't one, right? We go to tremendous lengths to design redundant systems for aircraft, and basically to design humans out of most of the important decisions where mistakes get made. But what is adequate for the most part when you're designing is, are you at least you have to meet the codes.
But if codes have words like shall or maybe or might or adequate in, then kill me now.
Yeah, their codes usually are designed. Codes are different. They're usually much more on the mandatory statements. Yeah. There isn't wishy-washiness. Where the wishy-washiness has occurred has been in guidance documents. Yeah. For example, in Ontario, they had pretty good stuff for schools, but everything was consider.
Passive
suggested.
Drives me nuts.
Yeah.
And that has no teeth. You don't do it. People won't do it unless they have to. It's like seatbelt laws.
Just for the listeners, when a contractor sees may or consider, that is Latin for absolutely no way is that going to happen ever in this world. So let's just be
You're absolutely right.
But look, let's talk about solutions. So let's get to the magic wand part of the conversation. So an architect, a doctor, an engineer walk into a bar.
What's the punchline?
an outdoor drinking terrace, not bar.
One in Dublin, probably.
With masks on.
You have a magic wand and you can wave it 3 times and change 3 things in building design. Omnipotent. You are God in this situation. So one at a time, we'll go. So on my screen, top to bottom, which would be Orla, Dr. Peters, and David. So Orla, what would you change? What are 3 things you would change if you could just change anything?
The first thing I think I would just change is information, educate people. People will make smarter choices if they know more. The second thing I think would be occupancy. Like, we kind of understand occupancy in relation to fire safety. And it would be a quick fix for many buildings, I think, to manage occupancy without having to do a lot of other interventions, because the space might be okay with fewer people. And it's a kind of measurable, quantifiable thing. So I think I would make that more visible. And what would I do as a third thing? That's a difficult one. I would like to, I suppose, move away from. I think engineering has in some ways been a problem on some of this, because once you say people engineering, people see equipment. And they see cost, and they see delay, and they see construction work, and all of that. And I think that has been a barrier actually to resolving some of this, because engineers tend to work on larger, more complex buildings, and they work on components. And I'd like to move the focus back to the people and buildings. And yes, sometimes we have to change components and systems and operation. But that isn't the first defense. We have lots and lots of first defenses that we could use immediately.
Totally agree with that one. Yeah.
Dr. Peters?
I think there's 2 main things at the design stage: design out infection. And that involves believing in the sources of infection being water, drains, and air. And surfaces, and that for me is the design. But a really massive thing is maintenance, because you can design a really fabulous and put a whole lot of money in the beginning. If you don't have the people who have the hours in a day to go and do the 2,000 tap changes, or TVCs, or the filter changes for our hospital is 14 floors, massive, over 1,700 beds. To open a hospital like that, you need an army of people with the time and resource, and enough of them to do the job that they have to do to maintain. So maintenance of complex building needs to be factored in. I think that would be my biggest wish list, is to up the role or the kudos of the people who keep the building running, because that is, and they need to have the resource to do that. There's no point in me as an ICD coming along and bemoaning all the things that I think are not perfect, if there's nobody there to actually be able to change it. So I think, and then the final thing would be, I think we've talked about it quite a lot, is feedback. So a way of feeding back and learning. And openness, just transparency about what we've learned, and because that's the ethical way to do it.
Great. David?
Okay. So I'm going to echo some of these. At the design stage, adding in to the integrated design process where it exists, adding in the infection prevention to all building types. But then just as we're starting to do with green buildings, where green buildings should basically have their plaque taken away from them when you actually come to see their real life performance after they're constructed, we need verification. We need ongoing management systems, not only for energy. We need management systems in place. That could be an ISO system. It could be something like that. That is tracking indoor air quality and related measures that are affected. So, and as going again back to the design part, thinking about the maintenance side, if you have to go on the roof in the middle of the winter to change a filter, that's not going to happen. So we also need to change our design process, just as that designers have to be aware of how a building is constructed to make sure that they're not designing something that can't even be constructed in a logical sequence. It looks like we need to make sure we're also designing in accessible maintenance and not just like drywalling off of equipment into a corner where you have to nobody ever finds it again. We need to have things that work as an ongoing system, then have a management system in place so that actually it's taken care of and monitored, and like any other sort of safety program or ongoing continuous quality program.
Great. Absolutely.
Yeah, those are great comments and all. And Adam, I don't know if we've talked about it. Maybe someday we'll try to get the engineers and the architects that were involved in Project OVE. And I don't know if you folks are familiar with that. ARUP is, one of the world's largest architectural engineering firms in existence. Orla, you've probably heard about.
Yeah.
Anyways, several years ago, they had some young students, recent graduates, that were given a budget, and their task was to use current technology to design and draft a building that was taller than the Empire State Building, but it was in the form of a human body. So the respiratory systems represented the ventilation systems, the arteries and the veins represented the plumbing and the heating systems, and neurological systems represented the control systems. And it was a fascinating project. And, they started out by scanning one of the engineers, his body, and that became the form of the project. And then they integrated all of the design professionals, including healthcare physicians, in terms of the anatomy and the physiology. And so the structure became the bones, and it was a fascinating project. I don't know of any other project in the world right now that has on such a large scale. Of course, they didn't build the building, but it had to be at that scale where both professions came together. When I look through this list of education and designing out infection and verification of systems, the human body has that in its natural state. As long as you stay healthy, you don't have to put batteries in us, and as long as we eat well and stay healthy, that our human systems function, other than in a world that people screw it up with bad design, not designing out infection, not making it easy to maintain, and the occupancy part, you're absolutely right, Orla, in terms of managing occupancies in buildings. There's lots of good comments here. And Adam, we could keep going on this. Unfortunately, we're running out of time. Yeah. And as I said, we need 3 hours, but we don't. And we're sort of at the end of our time here with you. I just want to say thank you, all of you, for, we know you're all busy, and your voices out there in the world of the internet have been strong. And I'm convinced, I know, and many of the people that we associate with online, that we've done our best job that we have in terms of saving lives in our own way, and hopefully preventing other illnesses and deaths in the future going forward. I think if there's anything that we've done, is we've done the best job we can in raising the flag and saying we need to stop what we're doing and we need to reevaluate going forward. Do you all agree with that?
Absolutely right.
Absolutely.
Yeah. So thank you for that. Appreciate it.
So again, for me, thank you very much for coming on. That was a very educational talk for me. I love it. So many things are foreign in my head, apart from the usual stuff. So it's all good. Thank you very much for coming on. And very, very, very educational, informative. Thank you.
The Edifice Complex will continue in just a moment.
Adam, it's time to thank some people who are on our side. Blue Rhythm Commissioning Software.
Blue Rhythm is the commissioning software I've been looking for. Most projects I consult on suffer from poor information and document management. Frankly, it's just chaos out there. Blue Rhythm removes this chaos. It is a secure, always available cloud solution designed to work on any computer, tablet, or smartphone. Their Android and iOS apps allow seamless transition between online and offline work. But what I like most about Blue Rhythm is their painless and fast onboarding process. Our team will bring all your existing forms and checklists into Blue Rhythm for you, or you can use or adapt their pre-built, pre-functional and functional performance test sheet templates. But it's more than that. It enables collaboration, automation, and easy planning and project management for all your projects. Blue Rhythm provides amazing support from a team that really understands your industry. To find out more, go to bluerhythm.com or call country code +1 612 460 8305. Also, you can hear from Blue Rhythm President Andy Martin on episode 26 of the Edifice Complex podcast. Robert, we there yet? I'm bored.
Adam, I know it's hard to believe, but the future has finally arrived in Canada.
How's that then?
Well, smart remote building and equipment management is now available from SensorSuite.
Go on.
SensorSuite, yep, they're an innovative smart building technology. We like them. They can monitor, control, and optimize anything in your building, saving you time and energy.
You mean SensorSuite are moving Canadian buildings into the 21st century?
Yeah, I know, another hard thing to believe, but they're doing it, and they're saving owners money with efficiency gains.
Okay, I'm in. How do I find out more?
Got to go to sensorsuite.com or call 1-855-773-6767. And also check out the July 2020 episode of the Edifice Complex podcast and listen to SensorSuite CEO Glenn Spry.
And now, back to the show.
That was an awesome panel discussion. We don't do enough of panel discussion. We typically do individual interviews, which are they're awesome too. But there's something that happens when you get a group of really smart people together. You made a really good comment about sort of the collegial atmosphere that's created by having multidisciplinaries on a panel discussion.
Yeah, I mean, immediately that was let's share ideas, let's find solutions. Everyone was cooperating. There was no look at me, no political defensive positions being taken. It was just like, let's explore what everyone's got to say and see if we can find some connections and some conclusions to draw. Perfect, right? Yeah. Why can't politics and the real world be like that? I have no idea. But I do. Yeah. Everyone's also awful in those places, right?
Yeah. It is. And, and all three of them were very thoughtful.
Yes.
In the words that they used. Which I loved. I love all three of them for that. When they do select their words, the messages that come out were loud and clear. There wasn't a lot of mumbo jumbo.
No, there was not a lot of waffling going on there, right? There was no waffling at all. So what was Dr. Peters being there? Because that is someone who's on the front line dealing with a massive 1,000-bed hospital, understanding the systems that are in there, talking about chill beams and that. It's not often you get that, because that is real feedback, right? Chill beams are leaking on my tiles, creating mold, creating infections. How often does a design engineer hear that?
Yeah. When I think back in my life, I remember when my son injured I think it was his hand. He was longboarding. For those that know what longboarding is, those people are insane. Both my sons are adrenaline junkies. Anyways, we were at the hospital getting his hand fixed, and the physician that was working on it, I noticed he had an engineering ring. For those that maybe aren't from North America, one of the requirements for professional engineers is they have a signing in ceremony, and they end up with the iron ring. And so anyways, I saw his iron ring and I said, "You're an engineer as well?" I said, "Yeah, I actually got my engineering degree first and then my license to practice engineering. And then I went on to get my medical degree." Bloody hell. There's, talk about two massive. Can you imagine that guy is, study curriculum? I mean, my God. But, when you think about the interrelationships between health and engineering, there's so many parallels that exist, and dominating the COVID world has not been, the Dr. Peters of the world and the Orlas, the architects, and the David Ostroms of the world, the engineers. It's been dominated by people, infectious disease prevention and controls and public health people, who just have not demonstrated an ability to play along well together.
No. The other thing that sort of struck me was, when I was managing partner at Cobalt Engineering, so we were a green design firm, right? We wanted to do the most sustainable designs possible. So we worked on a few hospitals, and because I've done a lot of hospitals in my past as a commission engineer, I understand that energy, yes, hospitals are energy hogs, not going to change ever, right?
Yeah.
What matters is the systems and the pressure regimes and everything else in that. And trying to get the sustainability people and engineers who are used to trying to deliver green buildings to understand that was really difficult, I found. We had to have like some workshops and say, look, there's a hierarchy of things that matters here. And, what matters is infection control, pressure regimes, building regulations and code, then green, right? There is that hierarchy that exists. And it's, for me, I understand it because I've worked in hospitals, but it occurred to me that most people who work in the sustainability, like give me a green building, don't think like that.
No, they don't.
That was a wake up for me.
Yeah. Well, Orla Hegarty said that was her she said some great stuff, but education was part of that. People need to understand these hierarchies, what is actually important in a building, and managing occupancy, which is bang on, not only in terms of the density in spaces, but obviously the ventilation requirement for that. And when we start talking about air changes, and Time Magazine, we didn't get into this. I actually wanted to bring this up. There was Nardell, I think was the author of it, and he was talking about air changes. And people need to understand that it's not just changing the air over, but it's how much air needs to leave that process, and outdoor air coming in. And again, it was used here, and it's used all the time, this concept of fresh air. And we all understand what that means, but we also need to understand that outdoor air is not always fresh. Mm-hmm. That we have to actually make sure. And we see that used, and but we have to, outdoor air is not fresh always. We hope that it is, but there are times air coming into the space has to be also treated, not just the air within the space, but the air coming into the building as well. Yeah. You think about forest fires here in Western Canada or the Pacific Northwest in general, actually last year were horrific, and there was nothing fresh about that air at all. But we understand the idea, what it means to have fresh air coming in, and that means the air has to be treated for both particulate odors and gases if it's necessary.
But it's interesting hearing Dr. Peters talk as well about, so in the UK, they have what's called health TMs, health technical memos, which are basically building regulations specifically for hospitals, and they talk about infection control, like how far should a bed be away from each other, and that is not how it's handled in North America, right? So what fascinates me in North America, we deliver coolth and heating through air systems in North America, right? And it is super okay to recirculate all that air, right? Even in hospitals, which is fascinating to me, right?
Yeah.
Knowing how they're horribly maintained. Whereas in the UK, they're in the health TMs, you're not allowed to do that. Right, you have this pass through. I was surprised they had active beams. I would expect to see passive beams in hospital. Yeah. And I think that must have been an engineering faux pas and slip, right? But there's a difference. So, what drives hospital design in the UK are these HTMs, health technical memorandums. They have super high status in the hierarchy of things that matter, right? And it's not like that in North America. And there's this fundamental difference in, all right, so the UK is more of a temperate climate, to be fair, right? So you don't have the extremes of humidity or cold.
Yeah.
But remember, Peter Simmons designed a radiant heating and cooling system for Bangkok Airport, everybody, so calm down. It is possible, right? Envelope.
We see lots of it now, yeah.
There are things, to change, for things to change as they need to change, i.e., more air change rates, pass-through air, not recirculated air, you're talking about changing orthodoxy and design culture, right? And that is really hard in, say, in the US, where the whole supply chain is geared up to put an air handling unit on that roof and recirculate that air, right? How do you change that? It's so hard.
Yeah, and that happens not in standards, because we have individual standards for air quality, and we have individual standards for thermal comfort and lighting, and all of the sensory systems are represented by specific standards. And the body has independent systems.
Yes.
The thermal comfort systems are different than the respiratory systems, although there's a little crossover there a little bit. But it's only in practice in North America that we try to mix what's in the body and what's in standards, and it never works well. It just doesn't, because it's not the fidelity of the hybrid system is not fine enough to represent the individual systems at the level that they need to be represented. And that's not always the case in other parts of the world, where thermal comfort systems are separate from ventilation systems, and so Orla Hegarty talked about less equipment, more on the people, which I thought was absolutely bang on.
Yes.
And that, in many ways, led to Dr. Christine Peters' comment about designing out infection. So to do that, you have to understand about infection, which means you have to understand pathology, human physiology, and building science and mechanical systems, and the choice of systems, the choice of materials, the hygiene of the building becomes incredibly important. And that, in many ways, was echoed in some degree by David Elstrom's comment in terms of designing for ease of maintenance. He's bang on. If you put for those that aren't familiar with where we are, like it gets to minus 40 here where I am, and further north of me, minus 50, minus 60 degrees Celsius, not Fahrenheit, Celsius. But at that point, it doesn't matter. It's so cold that you can throw a cup of water in the air and it freezes before it hits the ground. Well, if you put an air handling unit on the rooftop with a filter up there, and it's, and the filter needs to get changed, well, I can tell you right now that at minus 50 degrees Celsius with a 30 kilometer an hour wind or 50 kilometer an hour wind, my God, it's survival for a technician to go up on the roof to change a filter. Well, that's absolutely insane. Why would you do something like that? So he's absolutely right. So when you think about less equipment, more about people, more about designing infection out of it, again, the human factor, understanding hygiene of buildings, and then looking at design at ease of maintenance, all of those are the same subject matter, Yeah,
well, the magic wand conversation was interesting because that maintenance came up, I think it was to Peter's again, she said, you've got to raise the status of maintenance and facilities management.
Yeah.
It is respected and it's considered important and it's funded because, when you're running a 1,000-bed hospital, there are certain things that have to be done that are technical, they're highly technical. It's not a semi-skilled thing. It's a skilled thing, right?
Well, right. And that's when I asked the question about the skill level, like in the buildings in terms of, and, do we actually, in fact, have the skills necessary to operate these systems, but it takes a little bit different person to do that. Yeah. And we've had people on the conversation before about commissioning and training. Airports, for example, was a good one. But Dr. Peters made a comment about, that her job as a microbiologist and infection, her job is not to do the job of the engineering, but when she says we need 10 air changes an hour, there's a reason for that.
Yeah, there's science behind that, right?
There's science behind that. And so when she's talking to, the engineers and the facility managers about these environments that she needs to make sure that the patients have a good environment, for the operation that's required, but also for healing afterwards. These are not trivial things. And so all of a sudden the maintenance person isn't just, it's not about maintenance. It's about creating an environment where people can heal, become healthy again. That's a lot different than just mopping floors.
Yeah.
And there seems to be that disconnect between people's understanding about what it means to be maintenance in a building that requires or requires us to uphold the ethics of creating health and safety and the welfare of the people that occupy spaces, and it's important. And I think that they are in many ways the unsung heroes in buildings of the people that maintain them, and we don't treat them the way. I think if we held it at a higher standard, that education would then all of a sudden become important. Continuing education for these people.
Yeah, and it's got to be funded, right? I mean, I've never met a maintenance department that's fully funded in 40 years.
Yeah.
But the other thing, two things came out to me as well, sort of at the sort of meta level, really. Why is it the way it is? In my opinion, there's a lack of consequences. When you're going to see a perp walk of an engineer who's being prosecuted because he didn't design it to mitigate infection control, not going to happen, right? Or even a loss of license, or even a fine. For things to change, there has to be a perpetrator walk, right?
I'm glad you brought that up, because now I'm going to get on one of my soapboxes. But recently in Ontario, your home province there, the medical board have taken 40 doctors to task and have slapped their hands, and they've removed the licenses of a few of them because they were passing on misinformation. So my question here on this program is, if the medical boards are actually looking at disciplinary hearings for their members, why the hell are the infectious disease prevention and control associations not taking their members to task for misinformation? Because they've been spreading misinformation from the beginning, but you don't see them holding disciplinary hearings for their members. It's insane. And you're right on the. Yeah, you're right. And the same thing on engineering, we could get
the problem.
My blood boiling on this, because
this is the problem with our business, right? If the temperature, air change rate, or humidity is not right, people don't die, but they can actually in this situation, right? This is what
absolutely
Peters was saying. But people think it's a low consequence issue.
Yeah. Well, and here's. I think I'm going to start. There's going to be smoke coming out of my head here in a second, because my challenge to the people, which are on our Canadian building code committees, who wrote the phrase that buildings should be designed and built in such a way that they reduce the probability of people developing a risk of illness. It's about reducing risk of illness, and due to air quality.
Yeah.
Well, my challenge to the people on that committee is that with an airborne pathogen, people are getting ill. So have we actually met the requirements of the building code? And the answer is absolutely, I don't want to use a swear word there, but no, we haven't. We've failed the public because we haven't reduced the risk.
Yeah, so the question is, if you had a Sharky lawyer there, he'd say, sir, do you feel you've discharge your duty of care under health and safety? And the answer to that is no. Right?
Well, so and then here's the thing, right? So what happens is that standards become the defense, right? So so you've got architects and engineers, and you're saying, okay, well, people are getting sick inside of buildings. Have you exercised your duty of care? And they'll say, well, we've designed them according to standards. But what's missing out of that dialogue is that the standards were never there to address pathogens.
And they're not outcome-based.
Right. So
do this and then you're good. It doesn't talk about the outcome.
Right. So there's a whole bunch of tension that's created there between the building codes, relying on standards which aren't there for these life and death situations, and the statement about reducing risk of probability of illness. Now, the way you fix this, in my opinion, is, and this is where 5G, IoT play a role, right? The cost to measure temperature, humidity, air change rates, CO2 levels, pressure regimes is falling exponentially at the moment, right? Mm-hmm. So if there would be some way where health technical memorandums or ASHRAE guides mandated them things, then you find out who's swimming with
swimming trunks on and who's swimming naked, right?
Absolutely.
You find out who's doing it, who's not. I love these pictures on Twitter where people are holding up CO2 things. Saying, I'm in class, it's 1,200 ppm here, right? So you got to measure it to know it's not working, and then you can start assigning consequences to the right people, right?
Yeah.
So that's where I think it's got to go.
Well, you brought up the elephant in the room, the politics, and I don't remember exactly when I asked the question, but it was something along the lines that the authorities in charge of creating minimum standards should, in fact, they be the authority in a pandemic. And the reality is that in a pandemic, what we need Navy SEALs. We don't need politicians.
Yeah.
We have a problem. It's killing people, and the people writing the minimum requirements are defending the minimum requirements. That's the wrong people to have in charge.
Yeah. You need speed of action, speed of solution. You need technical application. Just taking long-term care homes as an example, right? We now know they are a prime vector of infection. They target the most vulnerable. And they are just horribly, horribly designed and ventilated and old and run down. So, I'm going to be fascinated to see if something actually moves on that post-pandemic. I have a horrible feeling nothing's going to happen. It's just going to quietly go away. But, if you had to assign some money, there's a place to assign it.
Yeah, and, and I think, Adam, and I don't know, maybe we take responsibility for this. I don't know. It's a big task. But we really need to bring together... In the past, there have been conferences where healthcare representatives worked along with the building science. So health sciences with building sciences at these conferences to discuss the commonality that we have, which is the health and safety and welfare of people that occupy buildings. There hasn't been a conference in a number of years. Yeah. And I think in order for us to move governments to mandate committees, make changes at a code level, because if it doesn't happen in code,
happening. Yeah.
Right, exactly. And so people need to understand that when it comes to building codes, the minimums become the maximum.
Yeah.
Let me repeat that. When it comes to building codes, the minimums become the maximum, right? And so what we have right now all over the world is we have buildings that are insufficient to deal with future pandemics. We have to change that. And the only way for that to change is to change the building codes. And that has to come from the political system. The politicians have to understand that the people's voice is that we don't want to go through a pandemic again. It has destroyed our economies. It has destroyed our healthcare systems. It has destroyed our economic systems. There's just so much destruction related to the transmission of an airborne virus. And we have to address that in our building inventories.
Yeah.
And committees, chair of these committees need to be a memo. There has to be a memo given to them, with the prime minister or the president or whoever's stamp on it and says, thou shalt destroy the concept of minimum requirements in building codes because it has resulted in all of this destruction.
Agreed. Absolutely agree.
We
got to couch that so it's a vote winner, right? Because that's all that matters in this game.
Absolutely. And I've said publicly, I'm putting aside my political affiliations, and the first political party that gets its freaking shit together to address the needs of society in these kinds of circumstances gets my vote. I don't care what you're, I'm done. Yeah. Right? No conservative government could have fixed the economic destruction that we have. No liberal government could affect or repair the social destruction in the healthcare systems. And no, new Democratic Party, and however you want to call them, whatever they're, could have fixed any of it. So no political party here can pound their chest and say we would have fixed it. Bullshit.
Yeah, I agree.
Don't give me this political crap, right? The science is there. We understand it. The health science, the building sciences, we know what was needed. And the political party that gets that first and foremost and puts the scientists in charge of these systems gets my vote. I don't care what their political story is. It's all bullshit anyway. So
it might be in the UK. There's a party called the Monster Raving Loony Party. It might have to be them.
Maybe the architects and the engineers and the healthcare profession needs to get together and put together our own political party. And
we need an engineering coup d'etat. Engineering.
I'm all on that one for sure. Yeah.
All right, man. Listen, I better wrap up. So that was a good one. I really enjoyed that. Actually, that was great.
Yeah, we got to do more of those. We've had. I think that's our second. Was that our second panel discussion?
Second panel. I'm thinking we should do more. Actually, maybe another one with Bill after his conference. That might be good.
Yeah, the one we had Roland Clift, Hema Murdy, Shelley Miller, and Bill Bonfliffe on, all PhDs, and that was a great one as well. And when you get these, and you're right, but same thing there, collegial, right? They all got along.
It's monster brain trust there.
It was a
small city with that brain power, right?
Well, you think about those 4 people and the 3 people we had on today, and collectively with everybody else that we've had on our show. I mean, there's a monster brain power there, and great. I mean, again, for parents, or kids that are in school, or young adults that are in school, the information you get out of this program, and that's why we're here. It's ultimately, right,
I mean, trust me, if one of my kids wanted to model themselves on anyone we've interviewed so far, I'd be all in on that.
Totally. Yeah. All right, Adam.
Take care. See you on the next one.
See you, man.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.